So yeah, good morning. I'm Rick Walker, and I'm going to be introducing this session and talking a little about the design process. So the plan for this afternoon is roughly this. We have a bit of talk for the next 45 minutes, which is an introduction to the design exercise we'll be doing this afternoon. There are a bunch of handouts at the front. If you haven't got all of them, we haven't finished printing some of them yet. They will show up at some point. So if you feel you may be missing some, particularly these slides, then check back a little later. As I said, I'll be starting by talking about sketching designs and design process. Then Tinni and Neesha will be talking about the challenge. Chris will be talking about an introduction to the specific exercise we're doing. And then there's a point where we have split into groups, hopefully taking into account people's range of expertise. There should be balanced groups. We'll see how that works out. And then what happens this afternoon is still a little bit up in the air depending on the decision. So today I'm going to be talking about design processes for visual analytics. This is not a particularly heavyweight talk because it's not a particularly long talk. But I'm going to be talking about three things. First, I'd like to try and provide a bit of motivation as to why we need a design process. Second, I'm going to present a design methodology. This is not the only one that exists, but it's the one we'd like you to try and use in the workshops this afternoon. And then I'll finish by giving a very brief example of some work someone else has done using this design process, so you can see the sort of artifacts that you may be producing this afternoon. So why do we need a design process? I actually kind of feel that Joe did a great job this morning talking about design. And design is operating at a higher level than a lot of the techniques we've seen. We've seen a lot of techniques for looking at data. If we've got this kind of data, we can use this kind of technique to visualize it. Design is about a little bit more than that, about higher level things. If we've got some data, we know we've got lots of techniques we can use to visualize it. We can do a time series plot. We can do a screen graph. We can do small multiples, or horizon graphs, or stem and leaf plots, or QQ plots, or scatter plot matrix, or parallel coordinates, or flow map, or clawback map, or graduated symbol map, or task diagram, or node link diagram, or nested circles, or arc diagram, or matrix view, or tree map. Or we could use any of these things, or any of these things. These are from a great website, a link at the end of the paper. There are hundreds of techniques, or we can design our own techniques based on the mappings we've talked about over the past few days. But a design process is more than that. It's about how are you going to use these techniques. Are you going to use more than one technique? Are you going to combine them? How are you going to interact with your tool? There's been a lot of good discussions about drilling down into data and about how one view is not going to be enough. How can you collaborate with others to produce your design? And how can you get feedback on it from experts? These are things that can benefit from a defined process. So that's why I think we need a defined process. And I'm going to present one. Before I go any further, I should point out this is not my process. This is methodology developed by a guy called Jonathan Roberts, who's at Vandy University in Wales. This is Jonathan. If we do a quick visual comparison, you can see that London is much, much sunnier than Wales. We can also see that Jonathan and I don't look that much alike. If I had a suit, and even better a beard, we're a bit closer, but we're not the same person. So I'd like to apologise in advance for any mistakes I may make in presenting his work. I don't know how many of you have seen this book. Has anyone seen this book? Or is it just me? Just me. It's actually quite a short book. It's only about 40 or 50 pages. And it's an advertising text from the 1940s that talks about how do you come up with ideas. This is, in the ad firms you have these guys who are ideas guys. They will come up with the idea for the campaign. And James Lloyd Young is one of those guys. And at some point another company said to him and said, we've decided we're going to come up with a technique for producing ideas. We're going to sell the ideas, not the ad campaigns. And encourage him to write down his process. And it turns out it's not a very complicated process, but it does have a number of distinct stages. I think there are 5 stages. They're steps that people would usually go through anyway when coming up with ideas. But if you skip some of the steps, the whole process just doesn't work. You end up later on unable to finish the things that you thought were going to be great ideas. So this formalization of the process is important. This book is like £3 on Amazon, and actually it's really nice read. What we're going to be doing today, is a 5-step process for producing visualization designs. We'll also produce 5 sheets of design information. And each sheet will have 5 elements. We're going to be doing this process away from computers. We'll be sketching on paper with pens. There will be flip charts, there will be post-its. There are pens in different colours. I know someone in the pub last night was very excited at the prospect of different colour pens. I should point out that beards are optional. If you really feel the need to add one with a pen, then that's fine, but strictly optional. So here's our process and our 5 stages. What are they? First, we talk to someone about our data. In this case, you're going to be introduced to the data set and you'll have experts to talk to. For the purposes of these diagrams, experts are the guys wearing hats. They may or may not be wearing hats this afternoon. But you talk to someone about the data and about the problem they're having with the data, about what they're trying to find out. Then you do some brainstorming as a team. We develop ideas from the brainstorming session and develop those into 3 designs, 3 distinct designs. I'll talk more about that later. You come back to your experts and discuss your designs, get feedback on them. And finally, you produce a realization sheet. You should have a handout that talks about this process in more detail. So if those are 5 stages, here are 5 sheets. We have 1 sheet that is for brainstorming, and we have 3 sheets that are distinct designs, and we have a realization sheet which is close to our final design. So our first stage, I said we talk about later what we want to discover. You will probably do this within your team, and also in conversation with the experts, and also there's a presentation on the data and the sort of things we want to find out. So this process has to happen first. If we don't have the data, we don't know what we're trying to solve, we can't produce any designs. Once we've had that discussion, we can move on to produce our first sheet, which will look something like this. It's about generating ideas, as many as you can think of. There's an interesting research that says that creativity in groups is worse than creativity on your own. So you might be better off in your groups going away, taking post-it notes each, developing ideas, and then coming back together and discussing them, or however works for your group. You can describe these ideas in words or pictures. Pictures are preferred, but words are also fine. Then you filter the ideas. If 2 people come up with an idea that is essentially the same, then you don't need both of them in there. Once you've done your filtering, you can categorize them. Ideas that are similar but not too similar, i.e. you think you can come up with some sort of categorization that encompasses them, can be split like that. Then you can combine and refine ideas. You might talk about, well, if I take one visualization from this category, one from this category, one from this category, they might work together like this. Once we've done our brainstorming and we've got this sheet, and the idea is that we have an actual sheet of paper or a flip chart sheet that summarises what you come up with your brainstorming, we can move on to the next stage, which is generating our 3 designs. Each of your design sheets should look like this. There are 5 elements to it. You've got layout, which shows kind of almost a sketch screenshot of how your application might look. You've got focus and zoom, which is more detail on the visualizations. You've got operations, where you can talk about what interactions do you foresee there being with your application. And then a discussion section where you try and think hard and write down some things that you think are the advantages and disadvantages of this design. Finally, I did say 5 things. There's some metadata in the top right corner where you say whose sheet it is, what the task is, what sheet number it was. And you generate 3 of these. And the idea is to explore different elements of design in each one. If you have 3 designs that are very close to each other, that's probably not quite as useful for the next stage. The next stage then is more discussion. The nice thing about having these 3 designs is it gives you a concrete point for discussion with the experts when they're coming around to talk to you about your work. As a result of those discussions, you should be able to refine your ideas and move to the 5th and final stage, which is the realization sheet, which looks very much like the design sheet. It won't just be one of your designs. Likely it will be a combination of elements of different designs presented like this. And instead of advantages, disadvantages, we switch that section out and replace it for some detail. Some things about the algorithms maybe, or how long we think it might take to build, that kind of thing. And then we're back to the start of our process. If we want to refine our idea, we could run this process again. But that's basically it. So, I started out by discussing why I think a process is a valuable thing to have when we're doing design. There are a lot of techniques, but technique is not process. And I've just presented a 5-step methodology to produce some designs. The last thing I'd like to do today is present a brief example of, I think this is a student applying this technique to some data. So this is the Guardian's University League table. Comes out every year. We can see that it's a multivariate data set. We've got universities, and each university has scores in different categories, teaching scores, student staff ratios, and so on. If we wanted to produce a tool to help us investigate this data along more complex lines than just sort the table, how might we go about it? Well, if we were using this 5 design sheet methodology, we would start with a brainstorming sheet. We would think about the things we want to know, the techniques we might want to use, and we would write down or draw as many ideas as we could. Then go through the process of filtering, categorizing, and so on, and end up with something a bit like that. Then we go back, talk to someone, or discuss it certainly, and generate some designs. So this is this guy's first design. It has a map and a table. So we've got some geographic context as well as table information. Second design is just a map. A map with some interactions where you can click on things and find stuff out. And here, we're not looking at it geographically at all. We're looking at universities and scores in different departments, which is a very different way of looking at the data that might also be useful. With those 3 designs completed, you can go away for more discussion and come up with, this was his final design, which actually combines elements of those other designs. So we've got a map, and we can drill down to produce stack bar graphs for different subjects of university, and so on. So this is a really brief example, but I hope that gives you kind of an idea of how we hope this process will work this afternoon. So, to summarize, there are lots of different types of, lots of techniques to do visualization. More than technique though, a process is a really handy thing to have to make sure we consider design properly when we're designing a visual analytics application. I presented a design methodology, the 5 design sheet methodology of Jonathan Roberts. And I finished briefly by showing an example of this methodology as applied to university rankings. That was about everything I wanted to cover. So I'd like to thank you all for your attention.
So I think we'll move straight on to Tinni, who will talk in detail about the actual data itself.
I'll make a comment.
Yeah.
The research that is taken to show that brainstorming doesn't work well is all research in which groups of college freshmen, who by definition know nothing, are brought into an academic laboratory and given toy problems to work on for about the duration of a college classroom. If brainstorming is genuine brainstorming, which is not easy to do, it takes practice and it takes good scaffolding, then it's very highly effective. Don't buy a lot of the nonsense you're fed about that.
That's interesting. I certainly read something about how a lot of psychology results are probably not as bad as they could be because of what you're talking about there, which is the experiments are all done on college freshmen. You have to do them as part of.
Most cognitive psychology is the cognitive psychology of the 18-year-old idiot.
Don't forget drunk.
Well, yeah.
Oh, we have a mic here.
Thumbs up.
So, can everybody hear me?
No, for low-level stuff, it's the same.
Yay.
What?
Right, so
Freshman
the sketching problem we're going to get you to do is this afternoon is based on the VASS 2012 data set. And the VASS 2012 is set in a planet far, far, far away. It is called Bank World. We were going to play the Star Wars theme, but George Lucas demanded royalties, so just imagine it in your head. So in a planet far, far away, you have Bank World. And the most important organization of Bank World is Bank of Money. It is the largest organization in Bank World, and it has approximately 1 million machines. Now, your task, as set by the CIO of Bank of Money, is to create a situation awareness visualization for the entire enterprise. So that's 1 million machines. And this is a considerable challenge, considering that the Bank World operation is running on the Bank of Money operation is running coast to coast on Bank World, so you have different time zones. And we are talking about 1 million machines that are pulled in 15-minute intervals. So at 15-minute intervals, the machine outputs whether it's healthy and some other number of connection it has active, as well as some other data. So this is roughly the number of machines per region that you have, and roughly the number of regions in the Bank of Money network. Everything's on the slide, so you don't have to frantically write anything. Everything's on the handout, so you don't have to frantically write anything down. Okay, so the data set you're given comprises of 2 tables. Now, the first table is a table of IP addresses, and this just gives you some metadata about the machines. So, for example, this is Rick's laptop. It is a work laptop of a office person, etc. is the kind of information you get in the first table. Second table is the health table, and in this case, you don't have any metadata information about the actual machine except for its IP. All you have is whether this machine is the condition of this machine at a given specific time. And that we've been referring to as a time point. So, and you are also given a map of Bank World. This is the data that's available to you. You're not actually allowed to have any data apart from this data, and given that this is a world far, far away, it would be pretty hard to supplement this data with other things. Okay, so a little bit more detail about the table. So firstly, you have the IP address table. So as I said, it has, the first bit of information is IP addresses. They have a range, and this is the range of the Bank of Money network. And then you're given machine classes, and they come in 3 classes: servers, workstations, and ATMs. Now, ATMs are only ever an ATM. However, servers can be web, email, file server, compute, or multiple. And workstations can be teller, loan, or office. And then you're given longitude and latitude information of these machines, so you can plot it on the map if you so desire. And then you're also on this IP address table, you're also given information about which business units the computers belong to and what type of facility within the business unit it belongs to. And then you're also given some information about the relationship between business units and regions, etc. Again, all of these are in your handout, so you're free to refer to it. Then we move on to the machine health table. Now, as I said, this doesn't actually have any meta information about the machines apart from the IP address. What it does have is, as I said, a time and point, and at that point in time, you're told how many number of connections that machine has. Now, you are not told whether the number of connections is internal or external or who it's between. You're just told a blanket number of connections. And then you're given the policy status of this machine. Now, the policy status is an integer value that ranges from 1 to 5. 1, the machine is functioning normally. 5, the machine has a virus. 2, 3, and 4 are slow escalating. 2, slightly deviating, a machine is suffering from a moderate policy deviation. 3 is serious policy deviation, non-critical patches failing. 4, critical policy deviation, and many patches are failing. So the machine, as you progress through the integer, the machine is getting sicker. However, this same explanation does not work for activity flag. Activity flag is, again, 1 to 5, but they are only an indication of what's happening on that machine. They are not escalating. So it can go from 1, everything's running normal, to 5, a device has been added. And then it can jump to 3, 5 invalid login attempts, and then it can go back to being going down for maintenance or the CPU fully consumed. So I like to emphasize policy status steadily increasing, activity flag not so much. Yes?
These are not mutually exclusive though.
No, they're not.
It can all happen, except for one, everything else can happen at the same time.
Right.
Can be,
so a machine can only have one activity flag at a given point in time and one policy status. But over the course of the data you have, the machine will have multiple policy status and activity flags, and a machine will have, at any given point in time, it will have a number of connections, policy status, and activity flag, and they're not mutually exclusive.
Yeah, in the real world this is probably the case, but in the data provided in competition, it was that you can only have one at one time.
Okay.
Yes.
Is there any relationship between the policy status, the number of connections, and the activity flag?
You'll
Do
have
we
to tell
all-
us, Mary.
Do we answer that now?
No.
No, okay.
There is,
Right.
Don't answer.
Sorry about that.
Okay, right.
It's a good question to ask,
Yeah.
but not one we're going to answer.
Right. Yes, and these are the time zones for the Bank of Money. Now, I'd like to point out, this is only the time zones that affect the mass. Now, BMT, Bank of Money Standard Time, mean time, is actually out in the ocean. So the time zones you see here are the only ones that affect this wonderful, large landmass. And last but not least, you also have some business rules to consider, which are that the business hours are Monday to Friday, 7 a.m. to 6 p.m., and all staff are encouraged to turn off their workstations at night. And although BMO engages in planned maintenance, it does not occur on a regular schedule. So take these information into consideration when you come up with your situation awareness, and think about what implications they might have. Good, this is the questions. Anybody have any other questions before I?
Okie doke. So I will just briefly go through what we actually want from you guys. So you've very briefly learned about the design process, design methodology, and Bank World, and all the data surrounding this that we're going to throw at you. And that's going to give you two group tasks. So we'll have a bit of a sort of VA Olympics. So you are going to be in some ways competing against each other at the end of this. So we'll be comparing the kind of the designs that you guys have at the end of the day. So the first thing you want to do is come up with a pretty good group name. If there's any equal teams at the end of the day, it may well come down to how good and how funny your group name is, so bear that in mind. But primarily, as Tinni said, we want you to design a situational awareness tool for a backward network manager. So what does that entail? Well, to start off with, you may just want to think about taking one of those time points. So taking time out of the equation, a single point, what would the, how would you provide situational awareness for backward's infrastructure? And if you think about how would they be made aware of things like hardware and software failures, external network attack, can you detect what an external network attack is or define that in some way? Does the data you're provided give you enough for that? Is there anything in the data, such as maybe where the machine's located or aspects, that allow you to infer that an internal network attack may well be happening? And then once if you have thought about a single time point, you can then move on to think about the full data set, which equates to 192 time points, it's 48 hours, and which provides you with a lot of data. So at that point, things like scalability may be an issue. Are you going to think about how you can cope with that, and other aspects as well? It may just be that you go straight for part two, it just happens that part one drops out in the wash, whatever works for you guys. But important message is we're not asking you to solve the challenge. We're not actually interested in the answers in any way. So for those of you who have tackled the challenges or won awards, so we're not interested in going, oh, so-and-so did this. We're interested in conceptually how you would design a system that would allow you to show these things, assuming that they're in the data. So that's what we're going to do. We're going to, Neesha will quickly, shortly put you into groups, and you'll be given the rest of the day to work through the design processes, have a look at the data. Obviously, we've thrown a massive amount of data at you with this vast data set to try and process it, think about it, what's important, what needs to be kept, what needs to go away.
Small point about the data. We have a small sample example data set for you. It's about 10,000 rows, and this is available in Excel format. So if you just want to use that as your thinking tool, that's fine. We are also going to provide you with login details to our Postgres server, where you can log on to access the full data set if you wanted to have a look at that. But if you wanted, you could just use the 10,000 row Excel data set to just get a flavor of the data as you think more about how you would design a situational awareness for that data. Yes?
I mean, are we allowed to use any data tools, just the prototype stuff for data sensitivity issues?
If it helps you understand the data, then I guess I don't know how much of an advantage it will give you. I think you'd be fine. You'd be okay to do that. Because again, the question is, you're not trying to find the answer. So I don't mind if you want to use something else to have a look at it. And the point is, you can technically do this without the data. You can just do it with the descriptions of what the data looks like. So yeah, that's fine. How it fits into your 5-sheet design process, I'll leave that to you. So that's your afternoon's task, and then at the end of the day, we will come back for some presentations where you'll be presenting your designs to the rest of the audience. So these will be very short, 5-minute presentations. Will be very strict with time, but every person in your group must say something during that presentation. I don't want people going up going something. But you can deliver the presentation how you want. If you want to make a PowerPoint, fine. If you want to use this thing, which will project A4 sheets of paper on here, fine. You could bring in your flip chart and just show your flip chart, although bear in mind those at the back may have difficulty seeing it. You could talk without any visual aids if you choose to.
We will be giving bonus points for musicals, though.
Okay. So some sort of jig or dance may well work. And if you want, you could use Prezi if you really feel the need as well. And you're basically judged very simply on how well your designs address the problem, how you make use of the methodology, your quality of presentation, your timekeeping, and I thought this was going to get mentioned earlier. Neesha made me use the word magic. She loves this idea of magic. So what sparked? What is it? Something new and interesting in there that's in your work that we can give you bonus points for, basically. And I think that's my section done.